Welcome to Electronics Techie. So in this video we are going to discuss about binary counter. So in binary counter we have to design whatever you want, means how many bits of binary counter you want, you can design that. But here in this video I am going to design the 4-bit binary counter. So for 4-bit binary counter we are getting 2 power 4, that is 16, means 0 to 15. It will count up to 0 to 15 from 0, 1, 2, 3 and so on up to 15 it will going to be count. So for that how you are going to write the design code in Verilog means you see first you have to write the module followed by module name here. So binary underscore is our module name, you can write any name here. So what are our inputs? Your output is depend upon the clock, so that's why you simply write clock. So input reset. So reset is used for if you want to reset your design or circuit will start from initial state. So otherwise it will be continue as your inputs. So next one output. What is your output? You have to count the bits. So 0, 1, 2, 3, 4 like that. These output will be the count. So next one always. So always block you have to write. So for whenever the change in the input, this block is going to be executed. If there is no change in the input, or what are the sensitivity list we are going to write here. If there is any change in particular these sensitivity list variable, then only this particular block is going to be executed. So here we are going to use count in this inside this always block. That's why you should write reg variable here after the output variable. So always at the rate. So for every passage of clock, so I already said that. So every passage of clock means, so whatever the rising edge should be a positive edge. So what is the falling edge, it should be called as a negative edge. So for every passage of clock or passage of reset, so this block is going to be executed. Whenever passage of clock will be going to be happen, then only this particular block is going to be executed. So what is R? So R keyword represent either condition. If there is a passage of clock or passage of reset. If any one of the condition is going to be true, then this block is going to be executed. If reset, so if the reset value is going to be 1, then what is your count value? So if you are going to reset your any phone or something, it starts from initial state. Like that same here also, the count is coming from initial state, that means 0. So your count will going to be 0, otherwise your count will be going to be increment. So 0, if it is 1, it will be increment to 2, if it is 2, it will increment to 3, like that. So followed by n, and what is the begin, you have to write here always block, it should be n, and module with n with end module. So for that, this is the test bench you have to write here. So module followed by and module name. So what are the input ports, it should be mentioned in reg. So what are the output ports, it should be mentioned in y data type. So why you are making inputs in reg data type means, so what are the variables you are going to use in always block or initial block. So we have to mention those variables as a reg data type. So that's why you particularly mention those as reg, otherwise you can use wire also. So you have to connect the design code with test bench code. So how you are going to connect design code and test bench code? We are going to connect by using the instantiation. So this particular portion is said to be the instantiation. Instantiation or initialization. Sorry, instantiation only. So how you are going to instance those design code means, how you are going to connect this design code and test bench code means, so first we have to write the design code module name. So what is the binary underscore count is our design code module name, you have to write here, and followed by port connections by name. So port connections by name means, so what are the variables here in the design code is connected to the particular variable in the design code. So like these port connections, we are going to connect the design code with test bench code. I already discussed about these port connection videos in previous videos. If you don't watch them, so go through that, then it is very simple to understand. So before understanding the code, you have to know something about basics. So that's already covered in previous videos. So go through those data types and port connections. You have to know means it will be very simple and clear to you. So next followed by always /5 clock equal to invert of clock. It means you have to generate the clock. So while you are going to generate the clock, you have to write like this. So for every 5 nanoseconds of time, 10 nanoseconds of time, you have to write like this. So always means for every particular time period. So here I say 5 means for every 5 nanoseconds of time, your clock is going to be toggle. So clock equal to 0 if toggle of what is the present one. So here the clock equal to 0. For next 5 seconds, it will be going to be toggle, means it will be 1. So for next 5 seconds, it will be going to be 0, like that. For every 5 nanoseconds delay, it is going to be exchange, means inverted. So next, what is the initial begin? So initially you glue clock equal to 0 and reset value equal to 1. Again after 10 nanoseconds of delay, you have to again make reset value is equal to 0. Means your reset value is 0 means your whatever the circuit, it will be depend upon the clock like that. So again after 50 nanoseconds of time, you have to stop. Means what is the dollar finish or dollar stop? Those are used for the stop the simulation. So end followed by these 4 lines are used to generate the waveform in EDA Playground. So if you are doing this code in any Vivado tool or any other tool, so no need to write these 4 lines. If you are doing this code in EDA Playground, so you have to mention these 4 lines. By using these 4 lines only, you are going to generate the waveform in EDA Playground. So followed by end module. So after that, this is the waveform you are going to get. So first, what you are giving clock. So for after here we can see the reset value is going to be 0, then your clock will be going to be changed like this. Count will be going to be changed. So 0 1 2 3 4 5 6 up to it will going on like that up to what you are giving here. So 500 nanoseconds means it is not of only 5 nanoseconds, here only 10. So 10 plus after 5 10 nanoseconds it is going to be stopped. So until then it will be going to be increment like this. If it is going to 15, then again it's go to 0 1 2 3 like that up to, and again 15, again it comes to 0. So like that 0 1 2 3 like that it is going to be circulate here from 0 to 15 and again come back like this. So I think it's clear. If you have any doubts, you can comment on it, and thanks for watching and thanks for keep supporting me, and then bye.